Alright, scholars, this is your last video before my return. Go ahead and pause this video so that students can do the objective and do now on their way in. Okay, so you've discussed the do now. So growth mindset, they view intelligence as malleable. Intelligence, that is spelled incorrectly. Intelligence is malleable, which means you can improve your intelligence, whereas fixed you cannot. So cannot get smarter. And research shows that this growth mindset is actually much closer related to biology truth, right? So that's how our brains work. You can actually get smarter by working hard, even if your teacher's not there. Oh, it's a picture of Kara. That's a nice little headband someone made for her. Okay, so I'm going to go over page 17 and 18 with you. There's two examples that I'll kind of walk you through, and then you're going to do some practice. This is just kind of explaining the bonding that you learned about last class, just modeling it with Lewis dot instructions, things like that. Alright, so some guidelines here. When you're actually modeling, every atom will either lose or gain electrons to get a full octet, which means that full outer shell, which is usually 8, with the exception of like helium. So that's where the 8 comes from, octet, ocho, octopus. You get the idea, it's 8 electrons. Draw arrows one way to indicate transferred electrons, which is going to happen for ionic, and draw arrows meeting to indicate shared electrons, which will happen for covalent. And then the number of atoms and bonds matters. In ionic, if you don't have enough electrons, just add more atoms. In covalent, if you don't have enough electrons, you need to make more bonds. You need to share more than one set. Alright, so when you're explaining, make sure you start with electronegativity. Remember, metals have low electronegativity, nonmetals have high, so metal equal low, nonmetal equals high. And be specific about the numbers of electrons and atoms. Don't just say, oh, they both have high electronegativity, so they share electrons. Well, are they sharing 2, 3, 5? How many are they sharing? Identify ions, and you can use the terms cation for positive and anion for negative, based off whether electrons are lost or gained. And then identify the structure, right? So crystal lattice for ionic, molecule for covalent, and then malleable solid for metallic. Okay, so let's look at this first one. So right away I see this is beryllium, that's a metal, and chlorine, that's a nonmetal. So this is going to be an ionic bond. So before bonding, I see they have Be with 2 valence electrons, chlorine with 7. They draw beryllium losing an electron to chlorine because it needs one more, which is why they must have had 2 chlorines, because if beryllium just loses 1, it doesn't get its octet. It has to lose both. So that's why you need 2 chlorines, which goes back to this idea here that in ionic you add more atoms as needed, so they added another chlorine because they needed it. The beryllium has lost 2 electrons, so it has a +2 charge. Chlorine has gained 1 electron. Electrons are negative, so it has a negative charge, but there's 2 of them, so that's the subscript of 2. Okay, and in their description, they better talk about electronegativity, electrons, ions, and structure. So let's see. Beryllium has a low electronegativity. It's a metal. Chlorine has a high electronegativity. It's a nonmetal. So they're just basically checking this off. So I'll just do that. I'll check it off. Beryllium will lose 2 of its valence electrons, forming a +2 cation. Well, 2 chlorine atoms each gain an electron. So they're only gaining 1 electron, but they're 2 of them. You see how they're being precise? Forming -1 anions. So they talked about how the electrons are being transferred, and they talked about ions present. The 2 ions then attract each other through the electromagnetic force, good vocab, forming a crystal lattice. So that's the structure. So that would be an example of how you could explain what's happening in ionic bonding and how you could diagram it and really show that you understand what's going on. So let's look at the other example, and then the rest of the time you're going to do practice. So here it says carbon and hydrogen can react to form ethene, C2H4. So that's a lot more atoms, but that's okay, we can do this. So we have 4 H's, they each have 1 valence electron, 2 carbons, they each have 4. And so I start by linking them together. Notice that the arrows meet in the middle because they both have high electronegativities. They're both nonmetals. Don't let hydrogen fool you just because it's on the left side of the periodic table. It's the one exception. It's a nonmetal. Now notice what they do here in the middle with carbon. You see how they have 2 sets? Because if I just had 1, carbon would not get its 8 electrons that it needs. And so it actually needs 2 sets to bond together. Remember, when you see this little dash, it represents a pair of electrons. So this is a pair of electrons. So then surrounding carbon, just circling this to show it to you better, you have 2, 4, 6, 8, so it has an octet. Now notice each hydrogen only has 2. But hydrogen only has 1 shell, and how many electrons do you need to fill up 1 shell? 2. So this is still a full shell, it still obeys the octet rule. Okay, let's see if they did all of this in the description that they need to do. Carbon and hydrogen are both nonmetals and have relatively high electronegativities. Bada boom, they just talked about electronegativity. Therefore, when forming bonds, the 2 atoms will have to share electrons with each other to obtain full valence shells. They've partially talked about electrons, but they weren't very specific. Each carbon atom shares 2 electrons with each other and shares 1 electron each to 2 different hydrogen atoms. Okay, that's a lot more specific. Since no electrons are gained or lost, there are no ions present. Check. And the structure is a molecule. Check. So they talked about everything they need to talk about. Okay, so for the rest of their time, I want you working on page 19 and 20, some good practice questions. You can use partners as long as you're working. If it seems like you're not getting any work done, switch to individuals. Make sure you use vocabulary, electronegativity, metal, nonmetal, etc. Use that growth mindset, so when it's tough, don't give up. Persevere. And anything you don't finish, you need to do for homework. So page 19 and 20, in addition to homework page 6, should be done by the time I come back. Okay, at the end of the period, make sure to get some feedback and reflect on your own behavior. And I'm excited to see you next week. Bye-bye.